And we are on. Okay, so Fine Young Scholars, you have two handouts in front of you. One says Kuta Matata on it, okay, and on the Kuta Matata worksheet for double and half angle identities, you may cross out 9 through 14. Sadly, we will not have the opportunity to do those questions. So on the Kuta Matata worksheet, we are doing 1 through 8, 2 of which we are going to do as notes. Okay, so we're going to do a couple of these together. That was Emily Reedy. Ready? All right, and then on the 5-5 double angle, half angle identities worksheet, you can cross out 11 and 12. Okay, and again, yeah, on the one that says 5-5 practice worksheet, okay, cross out 11 and 12. Not that those are difficult, it's just we don't need to do that, okay, and we're going to do a couple of those as well. Okay, so we're going to do 3 examples. Okay, on your salmon-colored thick cardstock formula sheet, would you all take that out and put it in front of you? Okay, and you will notice the tangent half angle formula. It's the last formula under the double half angles. They've got this nasty tangent half angle formula, and there are easier tangent half angle formulas than the one that they gave you. So please all write this down on your formula sheet, okay? Rather than use the one they gave us, we're going to use this 1 minus cosine alpha over sine alpha. And there's actually another version of it that you can use too. That is plus or minus. Sine alpha over 1 plus cosine alpha. Okay? So you can even cross out the one that they gave you. That's cruel and unusual punishment. Cruel and unusual punishment? Who? I don't know what? Ah, okay. Cruel and unusual punishment. But in this case, Jacob, this is something you will not have to do. Was he assigning something to you and say, and this will be cruel and unusual punishment? Did you stand up and say, no, it's not okay? Okay, I guess I better get back since I'm actually lecturing right now. Okay. Okay, everybody got this written down? All right, because actually it's going to take up space on my board, so I'm going to erase it while I'm doing this example. Everybody have it written down? Okay, so hopefully at home you guys did the same thing. All right, giddy up. So on your on the 2 handouts that I gave you, let's go to the 5-5 practice worksheet, and we're going to actually do as our first example, we're going to do number 4 on this worksheet, which is asking you to find the cosine of alpha over 2. Okay? You will have to do this on your test. Okay? So listen like a champ. Make sure this makes sense. In the instructions, it says the sine of A equals 12 over 13. And A, which is an angle measure, is in the first quadrant. Find each value. Guess what I'm going to do first? Yes, I love that. Yes, we're going to Whitmapoi. So off to the side, actually I should make an XY axis. Oh my goodness, I have no idea where that came from. Okay, so we're in the first quadrant, okay, and there is some letter A. We're in the first quadrant because they told us the angle was in the first quadrant. And we know the sine ratio from that angle is 12 over 13. So I Whitmapoi that. And then I say to myself, ooh, yes, why is this a... It is. Which Jackson is it? Anybody know? It's Janet Jackson, people, 5, 12, 13. Yes, clearly this is a 5, 12, 13. If you did not know that, you could just utilize Pythagorean theorem, but clearly most of you do. Right, Emily? Yes. Okay. So this is my Whitmapoi. This is a 5, not a 6. Let me write that again. Okay. There's my Whitmapoi. We are using the cosine half angle formula. So I go to my friend the formula sheet. I find cosine half angle. Okay? Anyone notice anything peculiar about that formula? Right off the bat. True. But it says plus or minus right off the start, right? And to me, it'd be like, well, what is it? Is it positive or is it negative? We're going to figure that out before we even start the question. Didn't they tell us that this angle lied in the first quadrant? Therefore, cosine is positive. So we know it's positive. Okay? I'm just going to write out the formula and then we'll bust it out. So it is going to be positive, the square root, 1 plus the cosine of fishy swimming upstream, all divided by 2. That is the Greek letter alpha, which looks like a fishy swimming upstream. Jacob. Pardon me? That was given. Okay. So let's do this thing. Actually, I'm going to go ahead, since we already know that our angle is the capital A, instead of a fishy swimming upstream, I'm going to go ahead and just put an A. I just had to say that because I like to say fishy swimming upstream. Okay, so here we go. Now we just got to plug it in. So what is the cosine of A? Well, clearly over here at our Wibapoi, the cosine of A is just what? That's beautiful. Beautiful choral response. 5 over 13, and is all being divided by 2, and that is all under the radical. Now, we just go back to the spring of Algebra 2. Remember those days? Conjures up great memories, I'm sure. So the common denominator in the numerator would be 13, wouldn't it? Right? If I'm adding these two things. So wouldn't this just be 13 plus 5, or 18 over 13? And if I'm dividing this all by 2, isn't that the same as multiplying by 1/2? And everybody with me? Okay, and then I see Ganage, because 2 gazinta, 18 9 times. Gazinta? Not gazintite, goes into. 2 goes into 18. Gazinta! Yes. Okay, so we have 9 over 13 under the radical. Do you see what I see? Ooh, yeah, you can separate the radicals because 9 is a perfect square. So as Emily said, this is Schneike's. 3 over radical 13. And then you go, because there's a radical in the denominator. And so the SLU is 3 radical 13 over 13. Okay? Yeah. Because they told us that the angle was in the first quadrant. And if we're trying to find the cosine in the first quadrant, that's when the x's, and they're positive. Okay? All right, let's go to, on the same page, let's do number 8. Okay? We're going to do 3 examples. 2 from this worksheet and 1 from the Kuta Matata worksheet. Okay, find the cosine of 5 pi over 8. All right, so scholars, this is very similar strategy to sum and difference formulas. Okay? Because we can't find the cosine of 5 pi over 8, because 5 pi over 8 doesn't have a reference angle that we can work with. Okay? But they tell us in the instructions for number 8, use half angle identity to find each value. Okay? So if they tell us to use the half angle identity, then off to the side I'm going to say, okay, fishy swimming upstream over 2, half angle identity, equals the angle itself, which was 5 pi over 8. If they're telling us to use the half angle identity, that means there is some angle that we would divide by 2 that equals 5 pi over 8, and that angle, alpha, would give us a reference angle that we can work with. Okay? So it's very similar to with sum and differences. So I'm just going to solve for alpha by multiplying both sides by 2. So fishy swimming upstream would be 10 pi over 8. And right now I'm not feeling it. Like, I'm not saying don't feel it, don't recognize that. But then if I simplify this, I get 5 pi over 4. And now, ooh, that's just a pi over 4 reference angle in the third quadrant. Alejandra. By solving for alpha, multiplying both sides of the equation by 2. Want to get rid of the divide by 2, so I multiply both sides by 2. Jay? Cub. No, I would suggest that you for sure should do what I just did right now. And then also today, when we're doing double angles, then I would have just said 2 alpha equals whatever the angle is and solve for alpha. Well, clearly we're not finished. No. Matter of fact, we've barely even started. So I haven't even busted out my salmon-colored, thick cardstock friend my formula sheet yet. So let's do that. Because they told us to use the half angle formula. So I took the half angle and set it equal to whatever. No, it says use the half angle identity to find each value. So since it's the half angle they're asking us to use, I'm just going to take an angle divided by 2, half angle, and set it equal to whatever angle we're trying to find the cosine of. Okay? We're using cosine half angle. We know it's in the first quadrant, so again, this is going to be positive. Was the last one when we did a cosine 2? Shnikes, I should have chose something different. Ooh! Alejandra, thank you. Thank you. All right, so can you guys tell me, just looking at this angle, what quadrant is it going to be in? Yeah, because wouldn't 4 pi over 8 be pi over 2? And it's a little bit bigger than that, so it is in the second quadrant. It's bigger than pi over 2. Okay? So it's in the second quadrant, and cosine in the second quadrant is negative. This is going to be a negative. So when I write out my formula, so it's again cosine half angle, negative square root 1 plus the cosine of alpha, all divided by 2. Everybody good with that? Alejandra. Okay, yeah, so you're asking a very good question. She said, shouldn't it be in the third quadrant because 5 pi over 4 is in the third quadrant, okay? This is what we're trying to find, right? We're trying to find the cosine of 5 pi over 8. So when you want to delineate what quadrant it is, it's the original angle that we're trying to find the cosine of. Okay, good point. All right, so 1 plus the cosine of alpha, I'll write it. Alpha was 5 pi over 4, all divided by 2. Everybody good with that? This was the formula. Now I just plugged in what I know alpha is. That's all I did. Okay, so here we go. Giddy up. Negative square root 1 plus cosine of 5 pi over 4. That is just a pi over 4 reference angle in the third quadrant. Cosine is going to be negative radical 2 over 2, all divided by 2. The common denominator in the numerator is going to be 2. So you got to multiply the denominator by 2, so I do the same thing in the top. Don't need to multiply this by anything, so I don't in the top. All divided by 2, and I'm going to do one step. To divide by 2 is the same thing as to multiply by 1/2, right? So I did kind of 2 steps in one there. Does that make sense to everybody? Everybody following me? Yay? Okay. All right. So So I'm going to have 2 minus radical 2 over 4. And I'm going to have to bring this up over here. Now what, guys? Anyone see any goodness? You can separate the radical in the numerator and denominator, right? Because we can take the square root of the denominator. So as nasty as this looks, the numerator is going to be, so it's going to be minus the square root of 2 minus radical 2, all divided by 2. You might have to do this in your notes, notebook. Does this make sense? Okay. Yay? I mean, that is a nasty answer because we got like radicals inside of radicals and such. But you can do it. All right, well, let's do one more together, and we're going to do it off the Kuta Matata worksheet. Okay? I think I'd be a bad teacher if I did not do one of these that was a tangent, because I think, if I remember correctly, the tangent formulas are nasty. So off the Kuta Matata worksheet, let's do number 2. It says the tangent of 60 degrees. Let's read the instructions here. And I think I need to make a point here. It says use the double angle identity to find the exact value of each expression. Okay? So they're telling us to use the double angle identity. Okay? Now let me make a point here. Don't we all know what the tangent of 60 degrees is? What is it? Yeah. What? No, tangent of 60 is what? Okay. So this is kind of silly because we would use a double angle identity when we cannot figure out the answer right off the start. Okay? So, you understand what I'm saying? We already know what this is. The answer is radical 3. But on the quiz or a test or any time in calculus that you would actually use the double angle identity, it would be because we can't take the tangent of this angle. Okay? So think of this as we know the answer. Now we better get the answer because that's what we're practicing. Right now we are practicing using the double angle identity. Does that make sense? Okay? Yeah, it's like verifying, Alejandro. That's perfect. Does that make sense? So when we use this double angle identity, which you will have to do on your test, it's not going to be one that we can come up with on our own. Okay? So this is kind of like verifying, Alejandro. Outstanding. That the answer should be radical 3. Okay, so use a double angle identity. So I take out my friend the formula sheet. 60 degrees, I know, is in the first quadrant. The double angle identity says that the tangent of 2 theta equals 2 times the tangent of theta all over 1 minus the tangent squared of theta. So here we go. I'm just plugging in 64 theta. So 2 times the tangent of 60. Shnikes. Was somebody going to tell me that ain't right? If we're using the double angle, that means I'm going to say that 2 theta equals 60, right? Because they told us to use the double angle formula. So I set 2 theta equal to 60, so theta is going to be 30. Right? All right. All right. So now I plug in over here. 1 minus the tangent squared of 30 degrees. All right, let me stop right there. Does that make sense? All right, so here we go. So 2 times, what is the tangent of 30? Anyone? Thank you. Radical 3 over 3. Okay, all over 1 minus, I'm just going to plug in for right now. Okay, so in the numerator, we've got 2 radical 3 over 3. And in the denominator, we have 1 minus 3/9, right? Which is 1/3. I'm going to go ahead and write that, okay? Everybody see that? So 3/9 which is just going to be 1/3. All right. So 2 radical 3 over 3 over common denominator would be 3. So isn't that just going to be 2/3? So 2 radical 3 over 3. If I invert and multiply, this is 3 over 2. And we get mass gannage. 3's gan, gan. 2's. Solution, radical 3, which is giddy up. We knew that was the answer before we started. Does that make sense? Yes, Liz. Hypothetically speaking. No. No. I think that they probably had in mind exactly what Alejandro said. We're learning how to use this. So we know that the tangent of 60 is radical 3, so now let's use the double angle formula to show that that's the case. All right, if you guys, anyone else have a question? Otherwise, I'm going to end this lecture for the good of the fellow scholars that are not among us. All right, so you guys have got your investment. I really don't think there were people first bell that finished this bad boy when they walked out. I don't know how much time we have left.